Hi, my name is Joon Colaianni, and today I'll be using SAS Enterprise Minor to determine whether or not gender plays a role in income variation. How I'll be doing this is through a decision tree analysis, and I'll be using a binary classification. Also, throughout this video, I'll be showing you the 4 concepts that I've learned, and I will also display them in the Enterprise Minor. To begin, the first concept that I'll be using is the examination of variable distributions. So I'll be making sure that the most important variables are selected by using the StatExplore node. And I'll be doing this to make sure that my data is meaningful and that my decision tree is accurate and at least displays the correct variables to correctly answer my hypothesis. So these are the results of my StatExplore node. And before I go over here for the graph, I'm just going to go down to this section here, which is the number of levels in relation to the variables. So as I stated before, my target variable is sex, so male or female, which I used as a binary classification. It's my target variable. And we can see here that there's only 2 levels, which is the same thing with income. It's also binary. You could either be above 50,000 or you can be below 50,000. But now we see that education, also marital status, occupation, which we also see here, there are many different levels for that section. So this will also play a role in how many branches and leaves my decision tree will have, which I'll also be showing you in the next demonstration. The second concept that I'll be showing you is data partitioning. What I've learned from data partitioning is that it arranges the data to stratify the target variable, which we've seen is male or female, to make sure that they are both well represented. Here we have the results of the data partitioning method. We can see here that the total number of data is about 3,000, so we have about 3,000 observations that we can use. And since it's good to have more data in the training set, because more time is spent on training rather than validation and testing, we can see here that there are about 2,500 variables in the training set. And like I said before, since my focus is to see if there's a gender disparity between males and females in relation to income, this is also good to classify and or separate male or females, also due to the fact that there were more males in this data than females. And we still want this data set to be accurate and show me from these variables if there is a disparity between genders and income. Now that all my variables have been placed, I'll be actually making my decision tree by using decision tree versatility, and I'll be controlling the number of branches, leaf sizes, and branch depths that my decision tree has. So, as we see here, there's a large variety of leaves that have been used due to the properties that I've been using in relation to male and female. So if we see here, there's a lot of relationships with our variables, and some of them are important and some of them are not. And if we go down, we can also see here that there are many observations, which can get a bit hectic when looking at the decision tree, as we see here. Not only do I have to go to the side to see everything, they also aren't even combining into my predicted value, which would be the income, which is what I'm really trying to focus on based on these other predictions. So if we just go here from the beginning, we can see that marital status does have a relation to how much income somebody makes. And I also forgot to mention that one of the variables that I took away was country of origin, just because that can also be a factor into somebody's income. So by looking at my decision tree, I can see that I really need to prune it. I really need to take down branches. I really need to clean it up, really just make it nice so that I can actually see if gender does have a relation to income. And maybe what I really have to do is just see from these kinds of things what variables play a role in somebody's gender, and based on that, does it affect their actual income? because there are many variables that can affect someone's income, and it might not even have to be based on gender. So I really now need to take a second look at what my decision tree is trying to tell me, what I'm missing, and also how all of these variables can relate back to income. As we just saw with my data set, my decision tree was not accurate. So now I'll be using the pruning method to reduce the size of the decision tree without trying to reduce the predictive accuracy. Now that I've pruned the data or taken away a lot of the variables, we can see that the number of splitting rules has decreased significantly. So if we take a look at the decision tree, we can see that marital status in relation to divorce now has an extra section, which is the hours per week that the males or females have worked. But I still see here that there's more accuracy that I need to improve. So what I could do as an extension to this is go to the interactive decision tree and make that an extension to my decision tree and accurately prune the split node so that I could just have the gender and income relate to each other to see if there's even a difference between male and females in income. So now if we just take a step back and we look at my actual training set, we can see here that what I have done is I have imported the data, I've used Stat Explore, I've partitioned the data, I used a control point for all the variables, and then I've made my decision tree. Now the only thing I need to do is an interactive decision tree to really make this data set more accurate. Thank you so much for listening, and have a great day.